What if I told you someone built a $270 million chemistry AI that started in a backyard trailer lab? And today, that AI is helping redesign products used by billions of people, from Tylenol to Neutrogena. Let's talk about the future of materials science. Welcome, humans, to the Neuron Podcast. I'm Corey Knowles, and joined as always by Grant Harvey. How you doing today, Grant?
Doing good, doing good. Very excited today because we are talking to Nick Talken, CEO and co-founder of Albert Invent, an AI platform that is transforming how chemistry gets done at some of the world's biggest companies.
Excellent. Well, Nick, welcome to the Neuron. Great to have you.
Yeah, guys, great to be here, and thanks for having me.
Excellent. Well, I guess to start out, let's talk a little about your origin story. I understand you and Ken started Molecule Corp in a literal trailer lab in the backyard. Is that right?
Yeah, it's a fun story. So yeah, Ken has been in the chemical industry for about 25 years. Before that, he actually grew up in his dad's paint factory. So the story goes even farther back, and maybe you'll have to get him on the podcast at some point to tell that part of the story. But yeah, back in 2014, he pulled a trailer into his backyard to start his third material science business. That company, as he said, was called Molecule, and it was really about changing the way that chemistry is invented, because he was frustrated that it hadn't really changed in his entire career in the industry. And so it was a great opportunity for me to join him and help him on that mission.
That's awesome. I'm really excited to talk to you because I feel like right now we've gotten to a point where the AI agents that we know of today, some people can use them well. Some people are finding the limits of how useful they are, especially in like workplace, B2B, SaaS, that area. But I feel like AI and science is the untapped kind of like area that is the most exciting, where there's the most potential benefit for good. And I'm just like really excited to talk about it from that standpoint, especially for chemistry. So for folks who aren't chemists, when you say Albert is trained on 15 million molecular structures, what does that actually mean? You want to
Yeah,
just walk us through that? Yeah.
yeah. So one of our core beliefs as a company is that you can't just take like off the shelf generic large language models, Gen AI, machine learning, whatever, and start applying it to science. I think if it was that easy, it would have been done a long time ago. And so what you have to do instead is you have to take advantage of the underlying data that exists out there in the world. And there's basically two forms of data that exists out there. There's the publicly available data. So that's the patent landscape, the literature, stuff coming out of academia. And then there's the enterprise data. And our mission at Albert is to help the largest and the biggest enterprises take advantage of both of those sources, so the public and the private. So when you mention 15 million molecules, that's actually coming from the public space. There's a lot of publicly available data out there, put out by government agencies and academia and the like. And we build foundational models of chemistry with that public data. The problem, frankly, though, and again, the reason it's not that easy is that generally the data in the public domain is the successes, right? There aren't many papers and patents that are publishing just all the failures. And if you remember back to your science experiments, I assume that most of the experiments you did in the lab and that everyone does, they're failures, right? That's actually where you learn
Yeah.
the most. And so just taking that data, even with that large number of publicly available experiments, it's not enough to just crack some of the problems that the industry faces today.
Wow. That's really interesting. So your platform is called an end-to-end R&D platform. What does that mean in practice? Say I'm a scientist for one of your customers like Hinkle or Kenvue. What does my day-to-day look like before Albert versus after?
Ooh, good question. So before Albert, and I think this is the industry at large, it resembles, I think, what it was when probably like Da Vinci was doing chemistry back in the day. And so, first you have to you got to go figure out like what are your ingredients? What are the things that you want to go test? And so generally that means you're going to walk over to your stock room and you're going to look at the shelf and you're going to figure out, okay, I'm trying to make a new let's take a new shampoo, right? As an example, I'll make a new shampoo. You need a lot of stuff in there. That's not just one ingredient. It's like baking a cake. You need to go get all those ingredients and figure out what you want to use. And there's two main problems as a chemist that you generally are trying to solve. Either you're trying to make an incremental change, so maybe you're dealing with a tariff issue or your supply chain problem, and I need to swap one ingredient for another, or you're trying to make like a net new novel integration, some product that the world's never seen before that has some amazing attributes that customers have been asking for. Regardless of what you're trying to do, you have to go figure out how do you work with your vendors, right? So it's going to your stock room, figuring out what you've got there, maybe figuring out what somebody else has done. A lot of sitting by the water cooler, so to speak, and asking, people, hey, I'm trying to make a new sustainable shampoo in this use case, and I'm looking for a polymer that comes from a green source. So it's not an oil-derived polymer, but it's coming from a sustainable, maybe bio source. Have you ever found something like that before in the industry? And so you figure that out, and we call that discovery, right? What has been done before, so you can stand on the shoulders of those who come before you. Historically, that's been very word of mouth, right? Then you figure out what you kind of want to do, and you'll take out your paper notebook and you'll start to sketch, what looks like a good experiment that I want to go run. I'm going to mix these things together. I'm going to apply it in a certain way. I might want to test it and characterize it. If it's a shampoo, somebody's eventually going to have to put it on their head and actually, bathe with it and like give feedback. Hey, my hair feels slippery, or it feels really, nice. And
Am I
it's
clean? Is my skin still here?
exactly all that
Yeah.
good stuff, right? To rank it, your skin quality from 1 to 5, all that good thing. And then you collect all that data, and you generally don't hit it on the first mark, and so you say, what did you learn from that, right? And that's a scientific method, very classical, everything that we learned in school. But you can see that's a very manual, slow process, right? Just to run one experiment could take you days, weeks potentially to go do that, and so it's expensive. You're not going to be generating millions of experimental data points. It's slow, and the way that you discover new information is still very analog and kind of how it's been done for a long time. And so with Albert, we change all that. We take that entire workflow from the early discovery of what's been done before in your company or in the industry to the final application testing that's being done with the shampoo in somebody's head. And we capture all of that data in a single source of truth. So a system of record for the entire ontology of information in the organization. And then that serves as the basis for all of what the next experiment does. So you've got a colleague in Germany now who's running a similar experiment. They're not going to use that same polymer if it didn't work well for you, because they know that it didn't work well, or maybe they know how it did work well and you can use it better. And so what we're doing is we're time shifting knowledge to some extent. And that might seem kind of crazy, but we're taking knowledge that used to be encapsulated in one person's brain or in a paper notebook, and we're distributing it throughout the organization so everybody has free access and can make better and faster decisions.
So if you're building anything serious right now, whether it's apps, APIs, AI features, this is one you really want to pay attention to. The Google Developer Program Premium plan is designed for developers who actually want to ship faster, not just sit and read docs all day. So when you go premium, you unlock the full breadth of Google's developer tools. That includes Gemini Code Assist and the Gemini CLI. So you can write, debug, and iterate with AI built directly into your workflow, not bolted on after the fact. And here's the part that really matters. You also get up to $540 in Gen AI and Google Cloud credits. That's real runway to experiment, to prototype, or even scale without worrying about burning all of your budget on day one. So whether you're just testing new AI features, deploying production workloads, or you're trying to move faster with fewer headaches, Premium gives you tools and credits right away that actually support how developers work today. If you're ready to build smarter and get more out of the Google ecosystem, go premium with the Google Developer Program. Check it out today at developers.google.com/program. That's developers.google.com/program. We'll have a full link for you down in the description. And now back to our show.
Do you get any pushback from enterprise clients on that who don't want to share their data? Because I feel like that is one of the biggest problems with, trying to, innovate in science is you have all these independent players who are trying to like gatekeep knowledge to a certain extent, so that they can benefit from it.
Yeah, I think inside of a company, I think if you're looking at one enterprise, you'll look like a Kenvue, for instance. I think that there's a huge push to try to democratize that knowledge or democratize that data, because they've realized that the market conditions are changing so quickly that if they're not doing that, how do they keep up with consumer trends and consumer behaviors out there? Now, when you think
Totally.
about the broader supply chain and you think about how companies share information with each other, that's net new. Companies have not been doing a very good job of that for a lot of the reasons you kind of talked about, Grant. I mean, they're scared of doing that. If I share this IP, how does it get exploited? Who can take advantage of it? But we are starting to see cracks in that old way of thinking. And so we've got another customer called Neuron, and they have put it's called Ask Albert. It's our LLM, and on their website, and all their customers now can interface with it. Now there's still a wall that you have to go through. You still have to sign up. They're going to validate that you're an actual legitimate customer and not maybe a competitor or something like that. But that's super exciting because now we're not just changing how a single company invents. You can start to think about how the entire supply chain invents. And for us as consumers, that's what we really need. Solving one company's problem isn't going to solve how the entire, manufacturing industry moves forward together.
How are you
Wow.
thinking about that in terms of like the efforts to onshore manufacturing in the US and like how much of yeah, just in general, what are your thoughts on that topic?
I mean, it's a big topic.
Yeah, 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 for
Um,
sure.
and I think, I'm a big fan of manufacturing, right? I started Albert in a lab bench in a trailer in the backyard in California, right? And so if we didn't
It's
believe
cool.
in like getting your hands dirty and making something for yourself, I don't think this company would ever exist. And so
Yeah,
I think that there's a big reason to try to have localized manufacturing. There's sustainability reasons of not shipping things all over the world. There's also competitive advantage, national security issues, all that good stuff. So I think we're seeing a big trend. I hope we don't see it where we start to build walls between companies or between
Right.
countries. That's not good for the global economic system. But I
yeah,
don't think we're seeing a lot of that. At least my vantage point in the industry is we're seeing people just reinvest in areas where they maybe haven't invested before, like in local
yeah,
manufacturing. And that's really exciting to me because job growth is great, and we want smart scientists to be located here in the US.
for sure. I saw that one of your customers had said projects that used to take 3 months, they've now been able to knock down to as little as 2 days in some cases with Albert. Uh, can you walk us through what's actually happening there to create that kind of speed up?
Generally, there's two things. So if we go back to kind of that scientific method I was talking about before, you've got one iteration of how do you go from an idea to something where you have data, and generally it's a failure, so you do multiple iterations there. And so our goal is to reduce the time per iteration and collapse the number of iterations down to as few as possible. And if we can do those two things, then science gets faster. And so in that example, I think each one of their iterations previous to Albert maybe took, 3 or 4 days, right? And so then generally they run 10 iterations or so, and it's a couple month long project that they'd have to run, right? And that's the old way of doing it. With Albert, because we are able to collaborate easier, they can collapse that down to maybe a 2-day iteration or maybe a 1-day iteration. And then because we can layer the AI on top of their historical data, we can start to recommend the experiments that the scientists can go run that give the highest information density per experiment. And that sounds a little weird maybe, but it's like that's the point of science. When you run something, you want to be on the bleeding edge. How do you get the most information to inform the next experiment, right?
Learn as much as possible, yeah, per round,
Exactly.
yeah.
Yeah,
And so if you
Yeah.
do that, then you can take 2 iterations instead of 10. And so if you collapse the time per iteration, you go from 10 to 2. Now you're at 2 days and you've launched a product, or you've gotten a product that is now commercially viable, which is super, super exciting.
wow,
So
that
are you
is.
doing that with the like, in simulation at some point,
Yeah.
or are you just okay, cool.
Yeah.
Yeah.
So what happens is we basically and that's where the machine learning comes in. And I think that this is important, especially for a technical audience that you have. LLMs are not just the root like or the solve for every problem out there. I think they're really good at discovery. They're really good at exposing information to broad audiences. They're good at helping give contextual and reasoning through what may be complex scientific problems. But when you want to go
Mhm.
to an optimization where you think you have something that's pretty close, there's actually much better tools than an LLM than to do high throughput simulation. And so in this case with that customer, they were running hundreds of thousands of simulations in minutes of time before they went into the lab with our software. And then they were able to go there and say, hey, out of a 10,000 or 100,000 simulations, I think that these 2 experiments are the most likely to be successful. And that's where the value comes in. So it's really about finding the right tool for the right job. And I think in today's world, if an LLM's a hammer, everything looks like a nail. And that's not necessarily the case.
100%. Well, they say you could tokenize
Mhm.
everything, right? You could tokenize molecules, but is that really the most practical way to do it if you have to have like trillion parameter? I mean,
Exactly.
how yeah,
Yeah,
like because your 15 million molecular structure model, that's not an LLM, I'm assuming.
There's a transformer sitting inside of it, but it's also there's a neural net that sits on top of that as well. So there's other ways that we basically vectorize what that how do you encode a chemical structure into a latent space that basically represents what that chemistry is. But
Right.
honestly, that's a huge data set. 15 million chemical structures, that's the entire public knowledge. That company we were just talking about that went from 3 months to 2 days, they had 30 historical experiments that we were basing that recommendation of
Wow.
simulation on. So this is small data that you have to be able to take and still
Wow.
give credible simulated experiments for.
So you guys built your own foundational models, is that correct? Rather than building off of another?
Yeah, so we use all the foundational LLM models out there. We're not in the business of building LLM foundational models, but when we're in the business of doing chemistry domain specific foundational models. And so that's again where you have
Cool.
to pair these things up. And it's I think that a lot of the reason that this problem hasn't been tackled is because there hasn't been this like concerted effort to go solve it for one domain. I think
Hmm.
there's been a lot of people that are like, "Hey, science, let's go try to solve AI for science," and even that
Right.
to me was too broad. Like we are just
Yeah.
doing chemistry and materials. So biotech, pharma, then we might dabble a little bit in those types of areas, right? If there's like a butt up next to them, but for the most part, those are different. Like a protein sequence is much different than a small molecule, which is much different than a DNA sequence. And so if you try to build some generic AI across all of it, you end up spreading the peanut butter, so to speak, and you don't get the value that the data actually can provide.
Do you think there might be a time where I assume, and we're seeing this in other industries as well, where industry leaders are coming together and like building this foundational approach that's hyper specific. And I would assume that's going to happen or is happening in biopharma. That will be and is happening in physics. Do you feel like there is a time where having those models all able to talk to each other could be beneficial in the future?
Mhm.
I hope so, man. I hope so. That's
Me
that's
too.
where I think.
Sorry, I went a little off the deep end there, but it was yeah, I
Yeah,
Well,
had to ask.
since we're
Thanks.
talking off the deep end, as part of this, what are your thoughts on cloud labs as well? I'm curious, like the idea of like doing all the experiments like completely autonomously, like yeah, just what are your thoughts on that?
yeah. So I'll try to address both those. So I hope that the industry has not had a lot of urgency for many, many years, this industry that we serve. And now that's changing. We're starting to see urgency because of margin erosion, because of competitive pressures in other regions in the world, and because there's other companies now that are popping up that are doing fully autonomous laboratory work with high throughput lab testing that are competing with the more traditional chemical industry. And so I think as part of the solve to that, companies like Albert are playing a role to help these companies jump, into the future a little bit, or jump maybe into the present from the past. And so, there's going to be a big role to play in cloud labs there, but it will never replace the actual experimental result. That's, I think, is the beauty of science. There will never be a world where you will just purely be able to do science digitally, I think, or maybe we're so far away that it doesn't matter about talking about that. I think that you're going to do 95% of the failed experiments, hopefully digitally. And then the ones that you actually go run are the ones that have that information density I was talking about that may not be the right answer, but they're at least going to test a space that you have no historical knowledge around. And I like to give people an example just to kind of like put in perspective how challenging this problem is. If I give you guys a task today and I was like, okay, you've got 100 different ingredients. I want you to make a recipe to make a cake. Um, and all I want you to do is pick a set of those 10 ingredients. So don't worry about the ratios and how much each one has to be. How many unique sets of 10 ingredients out of 100 do you think that there are that you could come up with?
An order of magnitude, like 1 to the 100th, right?
It's 17 trillion.
Oh, okay,
Wow.
no, so I'm way off.
Yeah. So it's 17 trillion combinations of just 10 ingredients. Now, if you think about what the ratios of those ingredients should be, then that blows up even bigger. And of course, there's
Right.
way more than 10 ingredients that you can choose from as a scientist. And so the idea that you could even brute force this problem without
Mhm.
having domain knowledge around it, it's just impossible. There's more possible combinations of chemistry than there are atoms in the universe. And so that's a super fun problem to work on because it's much different than other domains where you can kind of explore every possible route and just come up with this is the definitive best answer.
Mm, mm.
Is there
Well, that
any
makes
intention to save those that maybe don't make the cut for experimentation right now, but maybe have a lower chance of success a little bit, that maybe is whatever's below the threshold and still maybe have AI research those in some way in the future still to see if there aren't underlying opportunities that, while less likely, might still exist?
Yeah, I think that's the beauty of science, right? Because one failed experiment could be a successful experiment tomorrow.
Mm,
because the requirements change. And so, yeah,
yeah.
there's value in all that data. The key is if you're going to go if you're going to go into the real world, you're going to go onto the benchtop and run that experiment. You want that to be
Yep.
the most valuable experiment for today's problem.
For sure. For
Right,
sure.
right.
That
100%.
makes sense.
Well, that makes me think. So, if we're talking about a problem set that could potentially have 17 trillion possible, areas to go, what type of like are you competing with OpenAI for compute here? Like, how much compute do you need
Yeah.
for this type of stuff? Like, yeah,
Yeah, I think you wanna try to not play that game as much as possible, right? And
right.
I
Yeah.
think that you're gonna see, and now I'm talking about stuff that I don't have a right to necessarily talk about, but I think even with the foundational LLM providers, like, there is the laws of physics that you have to run. Like, you cannot have a data center the size of the planet Earth, right? And so at some point, you have to
Yes.
figure out, okay, like, how do we get more efficient about how we run some of these algorithms so that we can just okay, there's 17 trillion combinations. How do you exclude 16.9 trillion of those right off the bat without having to simulate them? So then you can focus on maybe just a billion. That is where scientific domain knowledge comes in. That's where the human comes into the problem. Their role is to say, okay, this is the infinite space. I know if I'm making a paint, it needs to have at least 50% water. Okay, right there, you've now constrained that problem much more than any possible combination. And I know it needs to have these type of attributes. And it can't have 100 ingredients because I can't manufacture that reasonably. So the scientist comes in with the real world, like constraint building, and they start to put constraints on it. And that's how you, first of all, solve the problem sooner. And it's also how you reduce the amount of compute to go like brute force this problem. And I think it comes into, the question we get all the time is, are we replacing scientists? For sure, we're trying to replace a piece of the scientific process that they're going through. Are we trying to replace the entire scientist? Absolutely not, because the scientist still needs to come in and give those guardrails for how the AI should go approach the problem.
Yeah,
Wow.
we sort of landed on that too, right, Corey? Where it seems like it's specific tasks that are getting replaced, not jobs. Like at this point, no AI can replace any single job at this point.
Yeah.
I don't know that I would say it in an absolute like that.
Fair
But
enough. Yeah, fair enough. I
I'm
will
not
make
going
more
to wrap it
bold.
in an absolute.
Yeah, that's fair. It
But
seems
as a
unlikely.
general approach, yeah,
I
I
mean,
would
Yeah.
say that is what we're seeing.
if we're headed to a place of like huge amounts of prosperity, right, where we're starting to automate these tasks, at some point we may get to a point where everyone's job has fully been replaced. So then the question isn't, is that the inevitable end state at some point in the future? The question is like, what's the last job that's going to be out there, right?
Yeah,
And I think
that's a
like
good point.
scientists and some of those types of fields, those are going to be some of the last jobs that are out there because they're very challenging roles to be in to just fully automize the entire process. And so I think if I was a scientist listening to this conversation, I wouldn't worry too much about it today. These generations, I think we're going to have a lot of cool tools to play with and not something that's just going to completely replace it.
Well,
Yeah.
what are your thoughts on OpenAI's stance that they're basically saying now in 2026, they think that they're confident that we're going to have AI that can make like, I forget the exact phrasing that they said, but like meaningful small
Novel
contributions
scientific
to science.
breakthroughs or something, or
Yeah, but then in 2028 or 2027, they're thinking that it'll have significant impact on novel breakthroughs. What are your thoughts? Do you think that those timelines make sense with what you've seen? What are your thoughts?
I think that if you look at the progress of technology on a XY axis, where X is time and Y is progress, you see
Mhm.
that curve, that exponential ramp. And so if you look at it from that perspective, you say, well, shoot, 2 years, 5 years, my God, we're going to immediately jump to this next stage. If you zoom in, though, on that chart, it doesn't look smooth at all. It looks like
Mm.
a bunch of kind of flat and then a huge step change and then maybe a slow progress and then another step change. Um, because things like transformers, right, were that step change, right? 5 years ago, would we have predicted where we are today if we had looked at the rate of technology improvement? We wouldn't have. We actually are probably way ahead of where we were. So then, but I think it's also false to say if you assume that we're going to continue to progress at the current rate forever, right? There has to be another step change. And so there will be more step changes. Does it happen in 2 years by 2028? I have no idea. I think nobody has any idea. If they did, they would have done it today and we would have already had it, right? Um,
Yeah, fair enough.
and so I don't know the answer to that question. At some point, there will be incredibly meaningful, advances because of AI. But I think that you shouldn't discredit the humans that are controlling it, constraining it, guiding it, and that type of stuff. And I think that you're going to see more and more, Nobel Prizes in chemistry won by humans plus models
Mm.
versus just one or just the other.
Would you list the model on the paper? Would you say like and authored by me and Grok or
I think
me
so.
and
Yeah,
X.
Yeah,
that would be
Yeah,
cool.
why
Yeah,
not?
I
give
think
people
Yeah,
so
credit
too.
where credit's due, right? Yeah.
yeah,
Yeah,
yeah.
I think so too, and I think it would speak to the credibility too, because 2 years down the road, we might want to remember what model that was and
Well,
understand what its limitations might have been, and maybe it still requires further study and repetition.
yeah, I think that's a good point. I mean, you gotta cite your sources, right? And these AI foundational models are becoming a source, and that's part of our long term vision also as a company, right? Is I would love to see us contribute significantly into the human knowledge sphere, but we're going to do that ultimately through our customers. Our customers are the ones that are going to make those innovations, and we're just going to try to empower them with the best tools possible. Which I think makes us a multiplier in the industry, that's fundamentally why I am doing this. Is it's the best place to be a multiplier.
So would you say that the Albert invents models are agentic? Like, is there any part of your system agentic? Like, how do you think of the way that people are working with that? Are they working with it as a co-scientist, or is it a specific tool? How do you look at it?
Yeah, so we look at our tech stack as three different components. We've got that system of record that we were kind of talking about before. How do we replace the paper notebook with something that you actually collect your workflow in? Then we look at our system of record that layers on top of that. And that's really where like the machine learning comes in. That's where the rule engines come in. I'd say the more traditional but still complex, software engineering gets applied on top. And certain things like regulatory information, you don't want an agentic system guessing, or guessing what the next token is going to be for like something that you're going to put on a passenger plane and ship around. That's a discrete rule. You need to have that. Then we
Yeah.
have our system of work, which
Yeah.
is that third layer that's at the top. And that's where you've got the RAG LLM, the agentic network that sits on top of it. And that's where we're starting to do like fully automate, certain parts of the work. So do people want to type data into a system? Nobody wants to type data into a system. Okay, so you got to get the data into Albert somehow. How do we put an agent there that maybe does that for you? It takes it from the machine and automatically puts it in there, or it takes it from a PDF on some online source and puts it in there in a clean and structured format. And so there's a whole agentic layer of our platform that sits on top. And our real competitive advantage, I think, is that we're doing all three of those layers. We're not just an agentic layer. We have the system of record as the foundation underneath everything else.
And you have the neural network kind of in the middle that you can work with.
Exactly.
Yeah.
Yeah.
Nice,
Cool.
nice. I have a question kind of dealing with data around IP, for example. I know, you mentioned it's been learning from some of Kenvue's data. How does that work without compromising their IP, for example? I know companies are protective of that kind of stuff for ages and ages, formulation research and
Yep.
whatnot. How do you how do you both use that to innovate and ensure that at the same time you're protecting, a valuable client's IP?
Yeah, that's a foundational question that every single customer also asks us, especially in today's age. And our answer is super simple. Their data is their data. The models that are built on their data become their models. We would never share that data with anybody else. Now, could we scrape things from online public sources to use for everybody? Absolutely. And that's what we did with the 15 million chemical structures and that. But the moment you add your data into it and you start getting insights out of it, that becomes yours and you own it. And I think, we couldn't do what we were doing without that. Now, back to an earlier question you had is like, what about when companies want to start sharing information with each other, right? We would love to facilitate that, but that has to be them kind of coming to us and the industry coming to us saying, hey, we want to share information more broadly. And then we set up ways to constrain that as well, where maybe it's only a very small subsegment of their IP that they've
Yeah.
decided to make public for X, Y, and Z purposes.
Not
Probably.
everything they've ever made. Yeah.
Exactly. But that has
Yeah.
to be a clear opt-in. There can't be a default status for us.
That makes sense.
Yeah.
That makes
Speaking of
sense.
Kenvue, I mean, what type of stuff are you working on? Are you like, has any of your stuff that you've contributed to been productized yet, or how's that?
Yeah, so I mean, Kenvue's, one of the earlier or the more recent, relationships that we have. We just publicly announced that just I think a month and a half ago or something at this point.
Yeah.
And so,
Congratulations.
Congrats.
thank you. Yeah, they're an amazing company, making products that we all use every day. And so they're in the middle of a big digital transformation, and we're a core piece of that. And so, we are right now deploying Albert to every single laboratory inside of their
Hmm.
entire facility. And
Wow.
by middle of next year, every product coming out of Kenvue is going to be touched by Albert, and we're going to be helping all those scientists with their innovation. And so, yeah, I think, you should next year be able to go to a CVS or a Target, and, I wish they would go for it, but invented by Albert would be, or invented with Albert would be really cool to have on the bottle there.
So do you want to see Albert listed on papers that win the Nobel Prize, or is that the goal?
That's not the goal. That would be a nice outcome, right? That's not
Wouldn't
the
hurt your
goal.
feelings though, would it?
No.
Yeah.
I think what would be the most meaningful thing is when a scientist, reaches out to us and just says like, "Thanks for making my life easier." Right? I've been, struggling for a long time with paper, Excel, haven't been able to move as fast as I think I could, and now you guys are making my life easier. And we have that type of feedback all the time, and that's like, I built this for myself. I was the first user of all of this, in the Ken's trailer, and so that's why I built it. And to be able to share that with the rest of the world, that's really what we're here for.
Let's I'd like to ask a question or two about kind of your business model. Are
Sure.
you essentially, so you're not selling access to a specific model, you're helping them craft a model that is correct for them
Yep.
essentially? Is that
Exactly.
correct?
So first we help them manage their data, because without data, you can't do anything. So that becomes like objective number one. And then we help them, and we're really helping their scientists build models for themselves every single day. And so, we've had in the last 12 months, I think we've had something like 120 million simulated experiments running through our platform. And so that's non-trivial, right? That's a lot of simulation that's being run. It's going to be in the billions and in the trillions in the years to come. And so those are all models that scientists are building for themselves based on their data plus their organization's data to help not run so many experiments that wouldn't lead to good results.
Wow, that's awesome. I mean, I'm personally so I just confessed to Corey right before we got on the call. I actually skipped my high school chemistry
Oh,
class. Like
man.
I got out of it, but it's because I did a digital science class. Learned a lot of really cool tools that help me now as a adult. But I did skip chemistry. But I've learned a lot about chemistry since then because I used to write for a company that's in the material sciences, trying to invent new battery technology.
Awesome.
And so battery materials is one of the biggest things that I'm focused on because energy density and finding the right materials that are, easy to source, not scarce, not just you don't become reliant on any one country for them. And you can also, pack so much more power in a tiny form factor is like that to me feels like one of the biggest unlocks that if we
Yeah.
can make a lot of progress there, we can exponentially increase progress elsewhere, because it just increases the amount that we can the amount of power that we can
Yeah.
store. If anything, are you doing in the battery space and materials, like energy
Yeah.
materials, I guess, let's say?
Yeah, I mean, some of this stuff isn't public, but one of the great public examples that I can definitely talk about is there's a company called Chemours, which is based in the East Coast, and they have an amazing battery lab out there. They're doing some incredible science around battery. That's all now being run through Albert. And one of the great things about the battery chemistry process is it is a pretty data intense process, right? And you think about cycle testing of a new pouch cell or a coin cell or whatever it may be, you're collecting a tremendous amount of data, and so a paper notebook actually doesn't work there, right? And you cannot use that. So you need some tool to use instead. And so they're having a tremendous amount of success. Fantastic company, and we are really proud to be supporting them, and then of course the larger sustainability and kind of electrification efforts that are happening beyond that.
Like chemistry and material science is a massive industry, but not one the average person
Yeah.
thinks about every day. Uh, Can you kind of help us understand the scale here a little bit? Like, what types of problems are being solved faster, and what does that mean for products consumers use every day?
Yeah. It is funny that people don't think about it, and even somebody like myself who like lives in it, there's like $1 billion revenue company that I stumble across every week that I've never heard of before, and it's like that
That's what it's
could
like
give you an
working in
indication.
AI too.
Yes. A billion of revenue, not billion of marketing.
Yeah, that's not what it's
Yeah,
like.
Yeah.
on market cap.
Yeah.
Yes.
And so it's the cool thing about chemistry is the foundation of the physical world. So if you guys just look
Yeah.
around where you are right now, I see a guitar in the background. The number
Yep.
of material science projects that went into making that, from the material, the metal that's of the string, to the plastic
Yeah.
of the guitar, to the coating on top of it, to, I'm sure there's
Mhm.
actually some very special materials that are some sort of acoustic dampening or acoustic
Oh, yeah.
properties.
Yeah, you've got the nut, all of the plastics on the back,
All of that.
the chemicals in the knobs. You would have
Everything.
The
I mean, the
wiring, you would
wiring
have
itself, the clothes on your on that you're wearing, these are fibers, right? These are spun fibers from some sort of synthetic cotton or maybe polymer or material. So everything in the physical world is chemistry. And that means it's one of the oldest industries as well, right? It's one of the things that humans have been doing for the longest. And so I think, the best way to think about it is anytime you go to a store and you look at everything on the shelf, right? That's chemistry. Maybe not the 2x4s, right? That were purely coming from a piece of wood, but everything else
Yeah.
is probably not just a simple, single component. And so that's super exciting because then you're helping to, we like to think of ourselves as helping to invent the physical world faster, or our customers are using our technology to do that. And so yeah, it's not like the world is slowing down, right? We all want better products. We want cheaper products. We want more sustainable products. And that pressure from the consumers trickles to the people like the Apples and the Teslas who are making those products. But they immediately then turn around to their supply chain and say, go solve this for me. And that's where we operate. We operate deep into that supply chain there.
Yeah, well,
awesome.
that's what I was gonna bring up a second ago was that like for let's look at Apple for example. Their limiting factor is actually battery life
Yep.
on their materials. So like they wanted to do this is publicly leaked and everything. They wanted to do AR glasses like 3 years ago,
Yep.
or last year released them, but they were limited by
Yep.
the actual like power to power them.
By the chemistry.
Um,
Yeah.
The chemistry
yeah,
was the limiter. Yep.
Yep.
yeah, so that's where I focus on, battery life and energy in particular is because that seems like that's a limiting factor for so much technology.
I think it's a limiting factor for almost everything, right? I mean, like Elon wants to go to Mars. Great, right? That's a super cool, inspiring mission, right? Multiplanetary. That is not a software problem. We very much know how to launch point a rocket and get it there. It is a pure materials problem for the most part, right? How do you make an ablative material that can withstand coming in through either the Martian atmosphere or returning back into the U.S. atmosphere? How do you have the properties of steel that can withstand, the temperatures and pressures of space plus, on the planet Earth? Like there's a huge amount of innovation happening right over there, right? Just around chemistry and materials to go solve that problem. We have to solve these problems faster. We can't take 10, 20, 30 years to solve these problems if we want to get done what I think all of us want to in our lifetimes.
Well,
I
so your
agree.
point on that, is it a data problem at this point? Is it a compute problem? Like what is the limiting factor actually to solve a lot of this stuff?
I think it is a data problem for the most part. People can't leverage their knowledge and their data. And then once you start to solve that problem, then it becomes like a laws of physics problem of how do you like kind of like I was saying before, collect the right data, the right next experiment as quickly as possible. And there's where high throughput laboratory automated testing comes in. There's all sorts of technologies that people are inventing there to help to solve the next set of data we want to capture. But if we're not capturing today's data very well, there's nothing to inform us of what we want to do next.
Well, I got one last full question for you here. If Albert works exactly as you hope,
Mm.
what becomes possible in the physical world that isn't possible today? What products or materials might we see in, another decade that maybe seem impossible now?
I'm going to answer that question by giving a slightly different answer. I think that
That's fair.
the the
I did just ask you to predict the future, so
Yeah.
yeah.
Woo.
What I would love to see in the future at whatever point is possible, is that you can invent with a laptop. You can invent the physical world with a laptop. Today, you can do that in the digital world very well. Before, that wasn't possible. 20 years ago, you couldn't just take out your laptop, log into AWS, and make some new amazing product. You had to have a server, and you'd probably work for a company that had access to a big server. I would love in the future where regardless of where you are in the world, if you have a good idea of how to invent something physical, you should just be able to do that with a keystroke and a click. And that is an inspiring world to live in because then you've taken what may be millions of physical world innovators today and you've made it so that anybody out of the billions of us can be. And then what products those people invent, I won't dare to guess, but it will be really exciting.
Well, imagine how many great ideas float around the world right now that are in the heads of people who have absolutely no idea where to start or what to do
Exactly.
with them.
Exactly.
This brings a lot of that to the forefront potentially.
Yeah. Yeah. And it's a world that is worth wanting, right? And I think with all the other stuff happening in today's world, you want to be excited about the future. So let's try to make an exciting future that we all believe in.
Molecule started as a 3D printing company, right? Back in the day. What are your thoughts on 3D printing today? We talked kind of about cloud labs, but like, what like do you think 3D printing is going to play a role in the laptop like developer where you can you know d- design the experiment and run the models on your laptop and then print it in your house to test it out? What are your thoughts?
Um, yeah, I think all maybe not print it in your house. I think that was a little bit of a fad, especially for like industrial type applications. But yeah, I mean, 3D printing is an amazing technology to, again, how do you take an idea and use something that's a digital application of chemistry? Just got to find the right use case, right? Making like red Solo cups with 3D printing is probably not a good use case, but making a dental device that's personalized to your mouth and your use case, incredibly good use case. Making our first prototype of a new idea. I don't think that I would doubt that there's really any prototypes anymore in the world of anything that's being made that 3D printing isn't touching today. And then as any technology gets more investment, the costs go down, the volumes can start scaling, and you start to play that unit economics game there. So 3D printing has a very near and dear place in my heart, and hopefully a big place in the future of the physical world as well.
Awesome.
Cool. Thank you.
Well, Nick, thanks so much for joining us today on the Neuron. Where can people go to learn more about Albert Invent and some of the amazing work you all are up to over there?
I check out our website, albertinvent.com. We got a bunch of great resources on there, and we're also hiring like absolutely crazy right now. We got a lot of really interesting roles for people who care about this type of stuff. So come help us invent the physical world. It's an exciting time.
I agree. Well, to everyone watching, thanks so much to you for joining us today as well. We really appreciate you. If you enjoyed today's episode, please like, subscribe, and do all of the things that help make us keep being able to bring you these videos and these amazing guests. Also, make sure you take a moment to pop by the neuron.ai and sign up for the daily Neuron newsletter and join more than 600,000 people reading it every morning today. But until next time, farewell, humans.